Welcome to Mineral Talks Live, the monthly live mineral webinar that brings you in-depth and in-person interviews with mineral people from around the world. Mineral Talks Live is brought to you by a joint effort among the Mineralogical and Geological Museum at Harvard University, the SMMP, and Blue Cap Productions. Tune in on the first Wednesday of every month and stay connected to your mineral world. Now, broadcasting live from beautiful Honolulu, Hawaii, the land of aloha, ukuleles, and shakas, this is Mineral Talks Live.
Hi, everyone, and welcome to Mineral Talks Live, your number one mineral talk show on the internet. I'm your host, Brian Swoboda, and I'm glad to see you here. You know, when Raquel, Eloise, and I started this program back in 2020, we had no idea how long we'd be producing these shows. But thanks to viewers like you, we are now filming our 91st episode, and we're still going strong. If you missed any of our past programs, you can always catch the rebroadcast on our Mineral Talks Live YouTube channel at www.youtube.com/@mineraltalkslive. And don't forget to click the subscribe button so you can be notified whenever we post a new episode. By now, it should be quite obvious that Mineral Talks Live is a 100% team effort, and I represent only 1/3 of our merry little gang. My other two beautiful and equal partners, as I mentioned earlier, are Dr. Raquel Alonso Perez from the Mineralogical and Geological Museum at Harvard University, and Dr. Eloise Gaillou from the Society of Mineral Museum Professionals, otherwise known as the SMMP. Together, we represent a majority female-owned endeavor in the mineral world, and that's an important distinction that we're all pleased about. For those of you tuning in for the first time, Mineral Talks Live is a monthly mineral talk show that airs live on the first Wednesday of every month. Our goal has always been to connect you with other members of the mineral collecting community via our interviews with some of the best curatrix, curators, collectors, dealers, miners, researchers, artists, and media people in the mineral world. One of the things that makes this program unique is that not only is this a live show, but it's a show where you get to interact with our guests. All you have to do to participate is to type your comments in the chat or the Q&A features, both of which are located at the bottom of your Zoom window. The chat feature allows you to instantly send messages to everyone watching the live show, so we encourage you to be as active as you'd like in the chat during the show. And while our guest and I generally don't see your messages during our conversation, throughout the show, both Raquel and Eloise will be monitoring the chat area and will be very active there. Occasionally, they may even interject a question or comment to us during the interview, so don't be shy if you want to ask something. Also, when you log on, we ask you to send a message to everyone, letting us know where you're tuning in from. This way, we can see how far we're reaching around the world, and we love doing that. If you happen to have a question directly for our guest, or maybe it's a little bit more detailed or needs a bit of a longer answer, go ahead and use the Q&A feature, and we'll get to those questions at the end of the show. Finally, towards the end of the program, you'll see a window pop up on your screen. This is our quick fire 5 question segment to see how well all of us know our guests. So test your knowledge, play along, and let's see how well we know today's guests. Today's show is an important milestone for me because our guest represents the final chapter in the Major Paris Museum trilogy. In our very first episode of Mineral Talks Live, we interviewed our very own Eloise Gaillou in her role of curatrix of the Paris School of Mines, and since that time, she's been promoted to director of the museum. Then in episode 56, we got down with Dr. Jean-Claude Boulliard for an insider's look at the Sorbonne Museum. Now we're going to talk with the curator of the National Museum of Natural History, my good friend, Dr. Cristiano Ferraris, who also happens to be one of the only people in the world who owns and wears the much coveted Blue Cap Productions logoed shirts. So please welcome to our show today a man who always brings a smile to my face, no matter what he's wearing, Dr. Cristiano Ferraris. Cristiano, how are you, my friend?
Hi, Brian. I'm fine. And thank you to invite me to this very important and quite international moments where we can share all about mineralogy, crystallography, and so on. So thank you very much to you and your colleagues to invite me to this event.
Well, it is absolutely our pleasure. I know that for a while we've been trying to get you on the show, and you have had an incredibly busy schedule. So thank you for taking the time out. I know it's evening time there in Paris, so we really appreciate you finally being able to join us on the show. So it's a very happy moment for us.
Thank you so much. First of all, I would like to apologize because as I was talking at the beginning, when Eloise invited me to this talk, I was supposed to organize something at the gallery, but because of alarm problems and the time schedule, I was not able to do that. Even I already bought a cask with a camera to bring you around the gallery, but it will be for another time. So this time I am at home, and I'm ready to listen questions and trying to answer. And well, let's start.
Well, fantastic. And again, I encourage anybody who visits, like, especially what I love to do is when I go to Sainte Marie, I usually try to use Paris as my hub city. So I'll fly into Paris, then I'll drive down to Sainte Marie. And then on the way home, I'll go back and I'll spend some time in Paris, which happens to be one of my favorite cities in the world. So I really, and hopefully, a lot of our viewers, by looking at episode 1, episode 56, and now episode 91, they will get a taste of what the 3 great mineral museums in Paris look like. And it's only enough to encourage them to go visit in person. So, Cristiano, even though you're at home, we're going to take a look at some of the photos of that you've sent us inside the gallery, inside the National Museum, and hopefully that will excite people enough to come down and visit. I've been there, as you know, many times, and it's always a wonderful, wonderful trip, and it's a treat to see the museum and spend time with you.
Thank you, Brian. Thank you, everybody. So, as Brian already introduced me, I am the curator of the National History Museum Mineral Collection in Paris. And this evening, it will be my pleasure to try to bring you in our building. Our building I think is an important it's important to say that the gallery in at the Jardin des Plantes in Paris is the first building that was built to receive mineral and geological and petrological collection. The first stone was posed in 1837, and the gallery was opened in 1841-42 with some difficulties. But after that, the gallery has been always open to the visitors, and only at the end of the 80s, the main parts was closed to the public for different reasons, and only in 2014. End of 2014, in 18th of December, will be 10 years that we reopen the one small part of the space to the public. But we are quite proud because even if are only 250 square meters, but we have more than about between 65 and 70,000 visitors per year. So there was a big, huge effort, but we are quite happy about this. If Brian wants to show you one image of the exterior of the gallery. The gallery is in the heart of Paris. Actually, Paris is a very particular place because you have 3 museums of mineralogy in about 1 square kilometers. One is the Mine Paristhèque, where Eloise, she is the director. The other one is Sorbonne University, and the third one is the Gallery of Mineralogy at the Jardin des Plantes, that is part of the National History Museum of Paris. So it's let's say that if you want to see minerals, you have to come in Paris. So maybe are not so. The three collection together, I think, represent the most important historical collection in the world. I'm not talking only about nice samples, but I talk about samples that can you can read in the sample, you can read an history, you can read where they have been collected, you can have centuries of history behind each samples, beside the labels and so on. So the first the minerals of the collection are quite old, and we lost traces, but most of them are from the collection of the king. Let's say at the beginning, Francois Premier was the first that decided to organize a treasure of the royalty of the kings, and he first bought stones from everywhere. Some of these stones have been lost during wars, have been used to pay wars damages and so on, but some are still present, and some of them are at the National History Museum of Paris. That's where are well exposed, and together with a nice history behind. Then, of course,
Cristiano,
yes.
Excuse me for a second. I think for this show, it's very interesting because I think we actually have two stars of the show. One is the museum, which we're talking about, and the other is you. And what I'd like to do is put a bookmark where we are right now, and let's come back to the museum. But I want people to understand a little bit more about you first. So let's back it up and let's talk about your origin story, how you first got involved in minerals and geology, and kind of what was the catalyst to send you down the road that you're now traveling.
Okay, so of course I am much younger than the collection, so and why
much prettier, maybe?
why I'm here, and what are the reasons? So the reasons are easy. In my family, my father is emeritus professor in crystallography at the University of Torino, and my mother was professor in natural science. So I get the sickness, let's say, when I was young.
You were born with the sickness.
Yes, let's say.
Sometimes it's hereditary, I can tell.
And when you're born and you are surrounded by people talking about minerals, crystals, and nature and so on, so you get curious and you say, I want to know a bit more about that. And so my studies started as geologist. Then I had my PhD in Switzerland, where actually I switched to mineralogy, because before I was more petrologist of metamorphic rocks. And when I arrived in Freiburg in 1994, and I started my PhD thesis on phyllosilicates, micas in particular, I started also to use a technique that at that time was quite novel, but now is something that is all scientists use almost, and was transmission electron microscopy. This and I felt I'm curious. My nature. So no, it's not my nature. My father always told me you have to ask yourself why stuff happen.
Okay.
And starting from there, I decide to correlate what is at the nanoscale and what is at the geological scale. So why at the nanoscale you can find some phenomena that you can relate it at the regional geological scale, and so that was a bit my history. After Freiburg, I changed again, but always talking, using a transmission electron microscopy. I moved to Siena in Italy, in Tuscany. That it probably is more known for the buildings and the food, but there are great mineralogists also there, and a very nice collection also there. And I start to work on meteorites on chondrites, and that made me very happy because I was chosen to participate to an expedition in Antarctica in 2001, and in the Ross Bay in Baia Terranova, and especially to look for meteorites at the zone of frontier mountains that is 72.5 south and between 160 and 165 meridians. So,
Okay, so Cristiano, we have an image of Antarctica up right now, and I'm going to kind of switch to a close-up. So where is this in relation to the overall map?
So in the map is the bottom of the map.
Down here?
No, go on your left, down. It is no, it's how to explain to you? Move your mouth on the right side.
Okay, this way.
And go down.
Down.
Down. Almost at the end of the image, and go right. Well, it's in the Ross Sea. It is Baia Terranova is maybe for American people, McMurdo station. That is not far from, is always in the Ross Sea, and was a remote camp. We spent there for 53 days, and well, the hunting was very good because we bring back almost 3.7 kg of different meteorites, 174 meteorites, if my memory is still good, and was a great experience, sincerely speaking, and was quite nice.
Now, let me ask you about this. Going to Antarctica to find meteorites, is there something about the South Pole of the planet that attracts meteorites more, or is it just it's the same worldwide? It's just easier to find them there because all you have is ice and snow.
It's the same all worldwide. It's just that meteors are blacks, and on the white ice you can see it better. so
it's easier to find them. It's easier to spot them in Antarctica than it is throughout the rest of the planet.
Exactly. Okay. And then in the Antarctica you have you have a physical phenomena that allow you to identify what are called meteorite traps. So it means that you have the glass that form, let's say, in the center of the Antarctica continent, let's say South Pole, and then the glass drifts towards the coast. And as soon it find an obstacle like mountains and so on, the glass go around, and the meteorites that are trapped within the glass, they try to concentrate just behind the obstacle. And so in that area, if you can show the image that you showed before of this one, okay, in the image on the right side, you can see the mountains, the frontier mountains that are part of a huge chain of mountains that is called Outback Nunatak. And when the ice try to go around to pass the obstacle, it accelerates on both sides. And what is the charge of meteorites in the ice concentrates just behind. And so if you just go there, you just go there. Of course, the logistic is quite complicated at temperature too, but your chance to find meteorites are quite high. And
interesting. So the ice is moving the meteorites, kind of conglomerating them together.
Yes. What is important to say is that where you collect meteorites now is not the place where meteorite felt. Okay,
right.
meteorites fell away and was taken by the glass and move it, and so thank you to the flow of the glass towards the seaside. So that is the main reason.
Do meteorites eventually fall into the ocean and collect like at the edge of the ice shelves?
Okay, now this is another frontier of meteor research. Is just there are two more frontiers. Is one is to try to look as it is for gold or other precious metals. Also, meteorites, they accumulate in sea sediments.
Okay.
So people are trying to collect to see sediments and try to find out meteorites. And the second one is when you are in Antarctica. It's important to say that Antarctica is quite dry continent, so you need to produce water by yourself. So how to produce water? You melt ice. Sorry. And when you melt ice, what you have at the bottom of your tanks are a huge collection of micrometeorites that are spheres that are maximum 1 millimeter, 2 millimeters of diameter, and then people like to collect these deposits and to study it, and it's a very good way to have a new meteorite specimens.
Interesting. Now, Cristiano, I've heard a lot of times that if you go to like the rain spouts on your house, and if you take a magnet down in the dirt, you'll get a lot of what look like rocks attaching to the magnet. And what I've heard is that those are, like you say, micrometeorites that land on your roof and then get washed down the drain spout from the rain. Is that true? I've never asked a specialist.
Well, let's say I cannot say that is not true. It's possible. So it's you need to be patient, because the possibilities that micrometeorites or meteorites fell on your house or are not too high. But yes, it's a possibility. Yeah. But you never to have limits when you want to find something. So, and we know very well this in mineralogy. And what I can say too is, because when I arrive Antarctica as mineralogist, I can see really. For example, Frontier Mountain, you have is a huge batholite, and you have this huge granite mass where you have pegmatites, and on wall you can see crystals that are really giant crystals. I remember yellow apatites that were 10 or 20 centimeter long, and
wow.
Well, at that time I was not curator, and I was paid to look for meteorites. But I was so impressed about these kinds of pegmatites that you can find there. For sure, Antarctica, fortunately, is protected area, and I hope that it will not be destroyed in favor of industry and so on. But is from the geological point of view, is so rich. And it will be a pleasure for all mineral collection just to put a feet on and just to go look around. Sincerely, is incredible. It's an incredible place.
I would love someday to visit there. And, it's interesting. I've never really considered meteorites very interesting for myself, but it's through exposure to experts like yourself who have taught me about meteorites that meteorites they are samples of the beginning of our solar system. And it far precedes life on this planet. It even precedes, or it's contemporary with the actual life and formation of this planet. And so when you're studying meteorites, how does that perspective come into guide you with in terms of what you're looking for?
Well, now it's long time that I'm not managing studies on meteorites, but let me say that I am an old school man, and I'm not used to try to find the founds to studies to make my research just using the word bio. It's, of course, now the study of meteorites is focused on the beginning of life. Why life it developed on Earth, where it come from. We are spending tens of billions of dollars to try to reach Mars and to try to sample comets, tails, and so on, trying to find the origin of lives. I think origin of life it comes from somewhere, of course, because or you trust in miracle or you are a scientist, and but not. This is my personal idea, and I'm not sure that lives come from extraterrestrial events. I think that our planet is a perfect combination and so rare in the universe to have the good distance from the sun, to have many incredible stuff where life could be produced without looking for life coming from extraterrestrial materials. That is my personal idea, and then for sure, I'm saying this. I get a lot of enemies, but I don't care, and so well, life on Earth is life on Earth. So is Earth science, and meteorites tell us about the origin of our solar system and particularly of our planets. That is fantastic. It's true because every time we find a rare meteorites, you have 1,000, hundreds of publication where you can find a lot of information very interesting. But for what is called organic material, that is the base of research meteorites now, for me is a bit. I'm not so convinced about that. So it's
okay. All right. So tell us about your history after Antarctica. I know that you were in Switzerland, back and forth between Italy, Singapore, finally Paris. Kind of fill in those gaps for us.
Okay, so when I was in Siena, actually a friend of mine came to Siena to give a conference, and he said, we are looking for electron microscopists in Singapore, and the salary offer was, I cannot say no, because at that time in 2001, my salary was 900 euro per month, and I was thinking to say, wow, you give me 3 times my salary and I will come to Singapore. He say, only? I say, okay.
So, I'm sorry, I meant 33. I slipped sometimes.
And so is the reason why I arrived in Singapore. Actually, it was a good choice because in Singapore, I find out another branch of mineralogy, that is mineralogy applied to industry. So we were working on synthesis of minerals, both for different kind of production. Mainly for us was medical processes. I think is in English. When at that time we were looking for apatites, non-stoichiometric apatites that can allow when you broke your leg, you broke your arm, you get an implant. You get an implant with this kind of appetites, because appetites are part of our body in our bones, and these appetites can accelerate the growth of the bones. And more recently, I just make a small digression, and actually now I'm going back a bit to with my colleagues, because it seems that also appetites are the reason why we have heart problems, because these appetites will concentrate cholesterol in our body, and so we are trying to find out which are the reasons. Well, after Singapore, because they my family asked me they told me that there was a place in Paris. I come back and I won the place, and I become a researcher at the Natural History Museum. And from 2009, I am in the curator, beside to be a researcher in mineralogy. So in next April will be 20 years that I am here in Paris, and I have been invited professor for 3 years again back to Singapore, and well, I touch all the 6 continents in my life, and I am proud of that. I met a lot of people. I have friends everywhere, and fortunately, we don't speak only of mineralogy, but we can enjoy about a lot of things. Especially like with you, Brian, I have very good memories of good talks about.
Absolutely, absolutely. I do too. So, in your role at the museum, you're both curator and you're a researcher. You talked a lot about the transition electron microscope. Tell us a little bit more about exactly what that is and what kind of answers that provides a researcher.
Okay, so everybody, I think, everybody who know about mineralogy knows about X-ray diffraction. Okay,
Mm-hmm.
well, as every source of you have X-rays as a wavelengths. Okay, that is 1.54 and so on. We don't enter the details. The difference is that using transmission electron microscopy, you don't use X-rays, but you use electrons.
Mm-hmm.
You focus electrons on a sample that is electron transparent. So what it means that is very, very thin, is 10, let's say, 10 minus 7 minus 8 centimeters of thickness, very, very thin. You need to prepare sample with very specific procedures. And the electrons, they have a wavelength that is much, much smaller than X-rays. So the interaction of electrons with the matter, in our case, are minerals, but transmission electron microscopy is used not only in mineralogy, it's used in physics and material research and so on. Means that you can have a direct image of the atom arrangement within your mineral specimens. And is an image, is called the select area electron diffraction image, where you can measure the distances of the atom planes and so on. You can get all the characteristics of your mineral species. You can also add other instruments. You can have chemical analysis. It's an instrument that is quite expensive, but is very useful, because with one, let's say, if you are lucky, one session, but most of the time is more than one session, you can get really a lot of information about your minerals sample, and you can actually, more recently, you can solve the crystal structure, and you can directly publish your results. Are instruments that cost, just to give you an idea, few $1 million, between $2 and $5 and $10 or $15 million. It depends what you put on. And now our computer, you use it with computers, but when I start, and here I felt really old, the computer was just a minimal part, and you had to do a lot of manual arrangements. So was a big job. Well, the job is, one side is to get the results, just means to prepare a good sample, to have a good instruments, to be passionate, because you have to work in the dark, you have to work alone, and and then I think the most important part is you have to give interpretation to the results, and just trying to be the more objective, looking to the object results. More recently, a lot of new mineral species that are accepted by the IMA Commission for Mineral Species are described using these techniques. And so it's you can imagine that are far the times where mineral species were of centimetric size or millimetric size. Now we are talking about objects that are few microns, so even smaller. So you need special techniques to analyze and to describe a new mineral species.
So the sample size are getting smaller and smaller. The requirements for the sample, for the minimum sample size, are getting smaller and smaller. So you must be discovering more and more new mineral species using this technique and your involvement with the IMA.
Yes, actually, one part of my job is that I am the French commissioner at the International Mineralogical Association, especially for the Commission for the Nomenclature of New Mineral Species. And this is a huge job because, well, I had one graph to show you, so, but no, it's not important. I will try to read it out. And until 2000, until 2000, you had about around 60 to 70 new mineral species per year.
Okay.
Yeah, and now we jump at more than 120 mineral species per year. So in 2009, for example, we had it was my first year as commissioner at the commission. We had 85 new mineral species described in 1 year. In 2022, we had 185. So it means an increase of 200% of new mineral species. And this is due particularly to the development of new investigation, new investigation methods that you can zoom much and much, you can zoom more and more in details in very thin specimens. It's rare in 1 year. I think that are less than 10 this new species described that have crystals, let's say, that are bigger than few millimeters. I am proud to say that one of the last was Lorantomazite, that is few centimeters wide, and was me and my collaborators that we described it in 2000. I don't remember. 20.
Yeah, I remember when it was newly described, and we did a interview with Laurent in Tucson, and they were beautiful blue and yellow minerals, and he was so proud, and it was very well deserved. And he gave a lot of credit back to you and a lot of thanks to you for helping that happen.
That is, if I can, I just want to tell you a short story about this sample.
Yeah.
And when Laurent came to me, and Laurent is a very good geologist, and he knows very well minerals. And he came to me and he said that they say that it's cordierite, but for me, is not cordierite. Actually, as soon I had the crystal in the hand, I say no, could not be cordierite because it's too heavy, it's too dense.
Oh, okay. You could tell by the weight of it already.
Yeah, yeah, and then I told him just leave me the crystal, and very rapidly I pass it on the X-ray using X-ray diffraction, and I find out that there was something wrong. Well, not something wrong. Was just not cordierite. And starting from there, we have done all the procedures for the new mineral species. But what is funny is that maybe not everybody knows that who was Alfred Lacroix. Alfred Lacroix is the biggest mineralogist in France, and he worked a lot with samples from Madagascar at the beginning of at the end of the 19th, beginning of 20th century, and he collects some sample and she put it on the catalog as cordierite. And after that, I was curious and I went to check in our collection. And some of these cordiarites actually are not cordiarites, are laurantomazites. Well,
interesting.
That's is a funny story, let's say, but is nice. And yes, the research that I do when I have time, when I am not busy to fill forms and to ask money left and right and so on, and is to try to use the collection, our collection, to find out new mineral species. And doing this, we at the moment, me and my group, we described 4 new mineral species and more than, yeah, this is the
I think this is the graph you were mentioning.
Yeah,
and
exactly.
This is the increase in terms of new species that are being discovered, correct?
Exactly. You can see this. It's growing up very fast, and especially there are some groups that are really prolific, and so it's every month is a big job because you have between 10 and 15 new proposals to read and to check, and it's time consuming, but it's quite interesting because you have you can be upgrade on all new discoveries in the mineralogical world. So
Cristiano, looking at this graph, when did the transition electron microscope start coming in to really make that difference? Because you could start sampling smaller minerals.
Well, let's say that is at the end of the 90s, beginning of the, let's say after 2000. After 2000, transmission electron microscopy start to be quite important tools in describing new mineral species, and especially the last 10 years, it explodes. It explodes after the new techniques that my colleague Mugnaioli presents, and so you can solve the mineral structure directly using the electron microscope, and this is a huge advance in both crystallography and mineralogy. So it's
well, I love that, because down here in the bottom left of this graph, you're showing in 2009 there were 85 new species identified, and Blue Cap production started back in 2007, and we're now 2004, but in 2024, but in 2022, that number of new species more than doubled. And to me, that's interesting because it gives me a time frame that within the time that Blue Cap Productions existed, that happened. And I still feel that Blue Cap Productions is relatively new, although it's not, but it shows me how quickly that technology has changed for the research world. And I think that's fantastic. That's really exciting.
Yeah, it's also thanks to you and Blue Cap's production that mineralogy is continue to be a nice science. We don't have to forget that mineralogy, after plants and insects, is the third branch of science that produce more new species per year. Okay, so many people would like to destroy mineralogy, let's say, because of different reasons, but they forget that if they use mobile is thank you to mineralogy, if they use computer is thank you to mineralogy, if they build their own houses is thank you to mineralogy. And so it's not necessary to look so far in the universe to find minerals when minerals are just under your seat and they just wait to be analyzed and promoted. So as you can see also in the mining world, now we are gold companies that are looking for gold and rare earth elements and so on. They are exploiting old careers and so on, where they look for gold at 6 ppm per tons. So it's incredible, and the all new mineral species now we are almost at 6,000. We have 6,100 plus minus 6,100 new mineral species, and looking to the prediction, we are just at halfway of our.
You're just halfway in terms of identifying all the potential minerals on the planet.
Exactly. Is but then you have also a lot of other minerals that normally cannot be found on Earth, but can be found on other, let's say, planets, asteroids, and so on. Because on our planets we have something that can keep us alive, but make is also our poison, because it's oxygen. Oxygen is something that oxidizes ourselves, so it's for this reason that we become old. We just get oxidized. And on other planets where you don't have oxygen, some elements can be stable at other oxidation states, so you can generate other minerals too. So the history of minerals is very far to be dead, as somebody would like. And I encourage all people that believe in minerals and they love minerals to continue to show how beautiful is this world, not only for nice samples, but for our lives. If there is no minerals, there is no life.
I think you make a very good point there. Certainly as mineral collectors, many of the collectors gravitate towards the beauty, but there's also collectors who kind of tend to gravitate towards, as we'll say, like the black uglies, where they want to complete a mineral suite. But I really appreciate the fact that minerals goes beyond just the aesthetics, and it actually has the potential to improve our lifestyles. And I love the museums where you actually see displays where they show what everyday objects you may have are only possible because of minerals.
Yeah, but heritage is something that is basic. It's like history. Unfortunately, history seems to not be taken into consideration, especially in these days, because people they don't read history. They just would like to make history. And in mineralogy, as for all science, heritage is quite important, because we can build something basing our knowledge just on heritage. I always say to somebody, when they say, this is a new minerals, is an example. I say, have you read the Russian literature? Because Russian have done a lot of stuff just before, but was not translated until 20 years ago. But especially in synthetic compounds, the inorganic chemistry that was developed in old URSS, but also in Europe, in United States, everywhere, in India, is humongous. It's just humongous. Just need to find out, and our knowledge can advance just taking into account what is the heritage. Where are the places where you can see the heritage? Are museum, old collections, libraries, and so on. You have we have to take care of this. It's not because I am curator, I am curator, but I never collect minerals and so on. It's just my son that collects some samples. But what is nice is that every day you wake up, and when you think you have finished something, actually you are even not at the beginning, and you have to go through, and sometimes it's time consuming, of course, but you always be able to find at least a portion of the answer to your question. Just look into the heritage that are in our museum, not only in Paris, all the museum of the world. This is even the smallest museum in the smallest village, I don't know where, is important, because there is something that is not visible elsewhere.
Yeah, no, I 100% agree that museums are they exist to preserve the heritage of all of us, including the minerals. And using that as a transition, let's switch back to the museum where you currently work at. I'm going to bring up, this is the exterior of the museum. Tell us again what part of Paris this is in, and then we're going to go and take a look at some of the photos of inside the museum, and you can describe the different displays that we're looking at.
Okay, so the gallery is at the Jardin des Plantes, is the botanic garden. Originally was the botanic garden of the King Louis XIII, and is located in the heart of Paris, let's say the 5th arrondissement.
Right.
And is easily reachable if you come by train, the Gare d'Austerlitz or Gare de Lyon. And the same area, you can have the Pantheon, you have Mouffetard, Rue Mouffetard to go eat and drink, and you have a lot of nice places to visit. Of course, the other two museums, as I was saying before, and of course I am there, so you are welcome all the time. You just drop me an email or you just call me, and I always happy to bring people around. So the gallery is very nice, neoclassic gallery, as you can see from the column in front and so on. And as soon you go inside, now the exhibit is on your right side, and it's called Trésors de la Terre, Earth Treasures, and actually is divided in two parts. In the middle you have this assemblage of what we call giant crystals. That is a collection that was bought in beginning of the 80s to Delef. That was a Romanian guy working he's still alive, 103 years old, and he had his birthday just in February, 28th of February, and he was in Paris too. And he was working in the carrier of quartz, and the quartz was extracted to produce lenses for microscopes, especially for microscopes. But as mineral lovers, he saved a lot of this huge specimen of quartz, but not only quartz. And he sold his collection at the beginning of in the 80s. And a choice of the specimens are here. So, and when you enter on your left side, you have all what is physics of minerals, a bit of history of minerals at the beginning of when the yes, this is the showcase where you have a concept that at the beginning of our planets of the solar system, there were only few species of mineral presence, mainly native elements like carbon, like as diamonds or and so on. And then there is an evolution. That is the article, the paper of Hazen that I think that everybody knows, so I will not enter the detail. But what was important for us, it was that minerals are something that have a lives. They born, they grow, and they get transformed. They never destroy. And that was quite important, and we saw this in. If you can proceed with the other photo, I don't know if I have the good one. Brian,
Which one?
More. Maybe. So no, it's okay. I will explain you. As this is more for talking about blue caps, tourmalines, you have tourmalines that are pink and then they become blue. So means that the crystal. This is the image. Thank you, Brian.
Okay, sure.
You can see in this showcase, we want to show that mineral has a life. It's not based on the watch time. It's not based on 24 hours as for us, as we live every day, but is much longer, it is much more diluted. But when you cut a tourmaline and you see, for example, equatorial section of tourmaline, you can see that you have area where you can recognize that are defined by different colors. What means that? Means that at that time, the elements, the chemical elements that were available to grow up the crystal were, for example, manganese, and then it gets a bit more dark. It was magnesium and so on. So you can see it's like when you cut a tree that you have the ring inside. The principle
exactly. It shows the life and what's affecting the growth of it.
Exactly. And so this was important. And you can see it with quartz capuchon, when you have transparent quartz with a head of amethyst, or with fluid inclusion, or you have that is a huge crystal of halite. When you have inclusion inside, and that means that halite grows so in a very fast way, and inglobates the solution where it crystallized from, or you have some inclusion in quartz and so on. So it means that minerals for us are static, because when we look at them, they don't move, but actually they are moving. They are changing their state, and well, when they are in the showcases, of course not, but when they are still in the pegmatites and so on, yes, of course, and so on. But it's nice. It's a concept that I love, and people, when they come, they get fascinated, especially young people, young students, that they have this static vision of minerals and samples. So they say, wow, yeah, actually it's true. And then they leave the museum with higher knowledge, of course. That is the main goal for us. And then sometimes they come back and they ask questions, and that is the more important, the precious things of my job, is that when people come back and ask you questions, because means that if they ask questions, means that you make them interested in what are you doing every day. So
I couldn't agree more. I think one of the great goals of any museum, and I know that you take great pleasure in this, is when the kids leave and they not only have a little bit more information, but you have been able to fuel their curiosity a little bit more. And that's one of the wonderful things about technology and the internet and social media, that if a young person is now, their curiosity is fed, they can go and they can find a lot more information. There have been plenty of major collectors today who started out in that same way, inspired by a museum, found online that they could buy minerals, and then they started collecting it, and now they have some major collections.
It's just to conclude about this, almost 20 years that 2 weeks per year, there are students coming for one week stage at the museum, and they are young students, 14 years old, and 80% of all students that I had, they're still coming back, asking for questions and asking for suggestions, and I am so proud about that, because
and that's a great thing, Cristiano, because it establishes you and the museum as something that is more permanent, and someone through the years can keep coming back and checking in and enhancing their knowledge. And yet again, I never really thought of it that way, but that is one of the great benefits to having fantastic museums like yours available to the general public.
That is the main goal of a museum, an exhibit. When you put things in the showcases, of course, is because they're nice, because they have an history behind, but should be something that stimulates the curiosity of people. If one person enter one museum only one time, means you have not done a good job.
Right.
A good visitor must come at least twice, because the first time he came and he say, "Wow," and then he leaves. He say, let's go back because." And then he come and ask, or he said, "Drop me an email or something." That is the when you can obtain this, means that what you show is good.
You've sparked that curiosity, exactly.
And it's important today that.
Yeah. Cristiano, I want to show this picture because I think this is very important for people to also understand that it's not just minerals at the museum. This is an absolutely fantastic table. Obviously, I've been there and I've seen it many times, and every time I'm fascinated by it. Tell the audience a little bit about this.
Okay, that is the other side of the exhibits, where the idea was to show the interaction between mineralogy and humans. So you have cut stones, of course, and you have this area where we have this. There are two tables like this one, and one showcase where there are some cups and carved stuff. These tables. Now there are only two, but at the origin, looking to the old documents, each table had a twin. So there were four tables at the beginning.
Okay.
But Le Comte de Buffon seems that he used the two others to buy something for the museum and so on. Well, this is all the history. And each color that you see in the image is a different kind of stone or minerals. And the blue one is mostly Afghanites and so on. And then you have a lot of other. You have corals too, and the base is black marble from Ardennes. And these tables were manufactured in Paris. And there is a third one that was too big to be shown at the exhibit, and it come from Italy and arrived with as the daughter of the wife of François Premier, Catherine de Medicis, Caterina de Medici. Of course, it come from Italy, and it's a really huge masterpiece of sculpture, let's say, is incredible. So it's another reason to come to Paris, because if you want to see it, you have to come with me in a special room, and because it's not available for the public. So
Yeah.
please come to Paris.
And absolutely, I can't emphasize enough how listen to Cristiano's work, come to Paris, spend some time with him, with Eloise. And well, now Jean-Claude has retired. Who's the new curator at the Sorbonne?
He's another Italian. He's an invasion. He's an invasion in
the Italian invasion.
Yeah.
Cristiano, we're a little bit past the end of the show, which is typical for me. But I want you to mention one other thing. One of the final displays in the museum as you're coming out on the right-hand side is a display of all the new donations that have been made to the museum. Talk briefly about that. And I know that you are one of the champions about educating people, especially Americans, about the tax benefits that they get by donating not only to American museums, but also European and international museums. So go with that just a little bit. And hopefully Raquel's not going to get too mad at it.
No, I will be very quick. As you know, the museum are still alive thanks to donation and sponsoring and so on. As a national museum, our budget is really limited, but a huge part of my time is dedicated to convince people to donate and to make gifts and so on and so on. And actually, it was quite successful because in almost 20 years, I get more than 1,800 samples that were donated or acquired with money from people and so on and so on. So donation is something really basic for all kind of museum, in mineralogy too, so which are the advantages for people who donate? Well, first of all, you can as benefits, if you are European, if you are French, you can get some tax reduction. Otherwise, you just will be part of the history. And I think that there are no taxes more important than to be part of the history.
Exactly.
And your name will be carved forever in the catalogs and in the memories and everywhere around the museum. And I don't know what can say more. Is important because it's important not just is important for everybody, because as we were saying before, people come to the museum to learn, and if we don't have if we can teach them, saying that people are so generous because they make donations to buy instruments, to show minerals, or to show what else, everything is welcome. People understand. And I'm really thankful because the new generation, the Z generation, as it is now called, they are quite sensitive to this. And they say, really? There are people that they make gifts? And sometimes, even a young student, they come with a small sample and they donate it. So,
yeah. Everything is welcome. Everything is welcome. Cristiano, we're at the end of the show here, and we're now going to do our quick fire 5 section. So these are 5 questions I'm going to ask you. You haven't heard these questions before, and I'm telling that to the viewing audience. Each question has 2 answers, okay? And so you tell us whichever answer resonates with you the best. All of your answers are correct. The viewers have all seen these questions up on the screen, and they've tried to predict how you're going to answer. Okay?
Okay.
All right. So are you ready?
Yes, I am.
Okay. Question number 1. Favorite hobby, pasta cooking or mineral hunting?
Mineral hunting.
Mineral hunting. Wow. Very little hesitation there. Okay. All right. Question number 2. Favorite holiday destination, the Italian Alps or by one of the many beaches in Italy?
The beaches, the sea.
The beaches. All right. You're going to have to come out and bring your family, visit me in Hawaii.
Yes, I know.
Yeah, I've been trying to get you to come for years.
And we have somebody that make a donation from sample from Hawaii that I saw that is online. So thank you so much. We have sample from Hawaii too.
Excellent. Favorite spice, cayenne pepper or black pepper?
Black pepper.
Black pepper. I heard my mom yell out her answer in the background. She was wrong. Sorry, Mom. Favorite mineral group, apatite or mica?
Appetite.
Apatite. No hesitation there. And finally, favorite drink. I don't care as long as it's Italian, or I don't care as long as it's in good company.
Gin tonic.
That's neither a well, I'm going to go with the good company then, because you're not going to drink a gin and tonic by yourself, right?
No.
Okay. All right. Eloise, are you doing the answers or is Raquel doing it this show?
We are both here, so
Okay.
either or.
Let's go through this. Favorite hobby, pasta cooking, mineral hunting with very little hesitation. Cristiano went with mineral hunting. What did our viewers say?
They went with mineral hunting as well. Yes, indeed.
Hunting, super. 1 so far. Favorite holiday destination, Italian Alps or by one of the many beaches in Italy? Cristiano went with beaches. What did our viewers say?
Well, they went for the Alps, so they got that one wrong.
Alps, okay. All right. Favorite spice, cayenne pepper or black pepper? Cristiano went with black pepper. What did our viewers say?
Well, we went almost for 50-50, but we got cayenne pepper just a bit more. So
Okay.
got it wrong.
Favorite mineral group, apatite or mica?
Appetite.
Appetite. Everyone got that one. Good. Good. And finally, favorite drink? I don't care as long as it's Italian. I don't care as long as it's in good company or gin and tonic.
Gin and tonic.
Okay, I'm going to give that to everybody. That's 3 out of 5. That means everybody who comes to visit Cristiano in Paris, you're entitled to free admission to the museum.
Okay. Yeah, of course.
That's a special Mineral Talks Live special right there.
Okay.
Or I guess we can see Cristiano in Munich as well, right?
Yes,
Yes, of course.
absolutely. And he's always in Sainte Marie, and oftentimes he's in Tucson. So when you see Cristiano, go up to him, buy him a gin and tonic, and say, "Buddy, let's talk about appetites. Are you hungry?" That joke never gets old. All right, we're going to go to the Q&A section. Cristiano, if you have the time, I think some of our viewers have typed in some questions that they would like you to answer. And so Raquel or Eloise, let's go into the Q&A.
Okay.
So we had many questions throughout the chat. So I will go through that a bit later on. I will go backward a bit. I had a question from Sandra, and actually she looked at the pictures of the museum later on. She didn't realize that actually the exhibition of the museum was not as big as it is actually. So she was wondering why at the museum you don't show that many different species of minerals. So what's the purpose of the gallery? But I guess you explained that a bit later. What's the purpose of the mineral gallery right now, the treasure of the earth? What can we see? And why don't we see that many species?
Well, that was a huge discussion when we decided to organize this space. Mainly is because we were forced to make a choice, and for the museography of the modern museography, to show many mineral species, mostly there are should be small samples, was not accepted. So we had to make choices. And what you can see is on one side, there was I told you is the nature of minerals, how they grow, the forms, some notion of crystallography, the origin of colors in minerals, and some particular effects of minerals like fluorescence or opalescence. And then on the other side is what I said is the more is interaction between humans and minerals. So you get cut stones, you get carved objects, you get a bit of history of our collection, and you have one part that is dedicated to meteorites. I would be so proud to reopen 1,500 square meters of the gallery showing all our 160,000 samples. But unfortunately, I'm not the one who decides, and my wallet is not so important, so I cannot. But I work every day for this, don't worry.
Yeah, thanks, Cristiano. Maybe we probably didn't tell the people how many different, how big is the collection that people cannot see? How big, how many different minerals do you have, and how many different mineral species do you have?
Okay, the total we have in our collection just for minerals 100 almost 160,000 specimens. And for mineral species represented, we are, let's say, sorry, a bit poor. So it's for this reason that I ask for donation, especially for people working in mineralogy. We have almost 2,000 species represented in our collection. And then the third part of the question, I forgot, sorry.
No, you're good. You're good.
That's
You're
okay.
good. And actually, if you want to see a lot of variety in mineral species, you can come to the Paris School of Mines Museum. We have over 1,000 different species on display. So that's why I think the three collections, they really complete each other. The Natural History Museum, where Cristiano works, is really nice because it's a nice discovery of the mineral world. And really, it's like throughout the different, throughout time and throughout history, throughout space as well. So it's a really nice discovery, explaining a lot of different things. And I saw in the comment in the chat as well, someone was mentioning pigments. And as you were saying, that is presented as well in the gallery. So very nice introduction to mineralogy. It's really perfect. If you want to see the variety of species, go to our museum, the Paris School of Mines Museum. You will see a large variety of species. And the third collection, the Sorbonne Museum in Paris, it's all about beauty. So you enter a very dark area and all the mineral specimens are lit and you can turn around them and really 3D interaction with the species. So it's, they complete each other. But that's why as well, we don't want to repeat what the other does. It's three different environments, which is really nice.
Yeah, they complement each other. And remember, when you go there, ask for the Mineral Talks Live discount for admission.
So related to that mineral species, I had a question in the chat. What is the best reference to mineral species today? It used to be the old Dana's book. So so that was Andrew asking the question.
Well, let me answer that. You have the IMA website where you can is updated every month with the new mineral species, and you have the lists, and it's quite rich also because you can find the first publication where the new mineral species was described and so on. The Dana, yeah, of course, is a must in mineralogy, of course, and so on. But not always is updates to the latest news. So it's otherwise you can write to the member of the IMA commission and ask for information. You can have the website. You can go on the website, Brian. Maybe you can give it to the public.
What is the URL?
You just wait. I just check.
And regarding books, actually, like nowadays, it's as Cristiano was mentioning, there are so many different species discovered each year that just a book cannot be published every year to compile all the different species. That's why we keep it mostly online with the IMA website and through Mindat as well. Mindat has once a new species is discovered, it's gonna be updated on Mindat as well with all the publications on the background. So.
Brian, I just sent you on WhatsApp the link. And yeah,
Okay.
of course, I forgot to talk about WhatsApp. Mindat. And yeah, it's a huge source of information, and it's really good, a very nice website where you can find all the informations, and is basic for all the mineralogists of the world. I think that they are using Mindat and I encourage people maybe to help Mindat to develop, because they are looking for people taking care to verify the localities and so on. So if there are people that would like to help, just drop an email to the webmaster, and I think he will be happy to accept your help.
Yeah, Mindat is a very powerful tool for all of us to use in the mineral collecting world. So get involved with it and support them as much as you can. This here is the website for the IMA. URL is cnnc.units.it. And this is what the website looks like. And once you get on there, I'm sure you can figure out how to navigate. There's a new minerals link right there on the top bar, and look at all them new minerals. God, they're keeping you busy, Cristiano.
No kidding.
No, I think it's important for people to know, because this is a job, is a big slice of job that not everybody knows. So I take the advantage to make some publicity to all my colleagues that work on this, because new mineral species are there thanks to this group that spends really a lot of time and to develop and to work on this.
Absolutely.
Yeah, and I think it's super important, because a lot of people that are on this show, they know you maybe at going to the shows, to the mineral shows, but behind a curator, what they see is like you running around trying to find the best mineral for the collection. But behind that, there's actually a researcher. There is actually someone that gives back to the community for different mineral species as well. So it was really nice to have you explaining all that part as well. So thank you very much. I had two last questions. One is related to the exhibit. Do you have translation in English inside the exhibit, or is it maybe on the website?
Unfortunately, we don't have it. That was a political choice at the beginning. I was quite disappointed about this, but unfortunately not. We don't have. And so when there are foreigners, English-speaking visitors, I'm always around trying to help to translate, but I cannot spend my time, all my time in the exhibition. So unfortunately, this is a really annoying point, but I understand.
Yeah, but fortunately, speaking of tools that are created with the use of minerals, we all have our portable mobile phones. And so Google Translate does very well at translating photographs that you would take of the labels and the descriptions. So it's better than nothing.
Is what I proposed for the 10 years, just to add a QR code, so people, they can scan it and they can have the label in all the languages. It will not be so difficult, but at the moment I had no answer about this. And
okay, we'll all write in to support your proposal. Just let us know what the URL is, or the email address.
Okay, a quick question from Paul. He was wondering when was the time that you collected the Ventifact in Antarctica? When was that time?
Was the end of 2000, beginning of 2001.
Okay, perfect. And Patrick had a question related to geology collections in universities. So the question was, of course, thank you for the lecture. You had plenty of thank you in the chat, great. Thank you very much. It was very nice, but we're going to go back to that later. Do the larger French museums accept PhD geology collections from the universities to save them from being ultimately dumped, which often happens in many countries, and possibly another form of heritage destruction? So basically, I'm wondering if we can collect, if the museum has the capacity of getting large collections from universities.
Well, it depends what large means. The geological collection of the National History Museum is around 800,000 specimens. So you can imagine that is something already huge. But yes, normally, as we try to preserve heritage, I think to propose it is the first step. Then, if it is accepted or not, that it doesn't depend on me. If it was me, the person who decided, I will say yes. But behind every museum there are a lot of politicians, so it's quite difficult. But try.
Yes, thank you. And at universities, usually, at least in France, you have to preserve a collection when it's actually well curated. The collection has to be preserved. You cannot, by law, you cannot dump it away. But nobody higher up in the direction of universities, they don't necessarily know that, and things like that happen sometimes, dumping collections. But by law, they are protected, actually.
Yeah, of course. What is heritage is you cannot just throw it away, and unfortunately, not everybody know that. Also, people working at the museum, they do. Sometimes I find out in the dustbin a lot of stuff that I feel forced to collect it, and to put it away. Well, but normally for the law, we are not allowed to destroy samples that are just, let's say, no longer nice or so on. Or, no, we have to keep everything, and in the best way we can. Is not always easy, and possibly to all the documents that go with each samples too. So it's really a huge job, and to put all together, because now it is easy using internet, but until 20 years ago, all the information were written. So I can let you imagine how many tons of papers and inks have been used to describe this collection. So all these documents too, not only the samples, but all the documents that are going with them, we must take care of them, and we take care of them.
Well, thank you very much, Cristiano. I think that was mostly the main questions. We tried to answer some of the questions in the chat during your interview as well. So thank you very much for your time. That was amazing. Thanks.
Thank you to everybody. And you are welcome in Paris to see me, Eloise, and all other people working in mineralogy. Of course, if you want to go to see Brian in Hawaii, is also nice. So no problem.
Everybody is invited to come to Hawaii. You can't all stay at my house, but you're invited to come to the state.
Okay.
Cristiano, thank you so much for joining us today. And thank all of you viewers for tuning in. Tune back next month. I think it's November 6th is the first Wednesday of November. We're going to have another exciting episode for you right here on Mineral Talks Live. Cristiano, I will see you in 3 weeks in Munich, and first round of gin and tonics around me. Take care.
Take care. Thank you so much to everybody. Bye.